So here are some basic shortcuts with logarithms. Any number to the first power is itself. You know, x to the first power is x, 7 to the first power is 7. So because of that, log base b of b is always equal to 1. Because if you rearrange that into exponential form, it would say b to the first power is equal to b. So if your base is the same as your big number, then it always equals 1. Okay? Log base b of 1 is always equal to 0 because any number to the 0 power is equal to 1. So whenever you take the log of 1, no matter what your base is, the log of 1 is equal to 0 because anything to the 0 power is 1. Okay, now you understand, I'm going to put this off to the side here. You understand that if I take the square root of x and square it, I just get x. Okay, I would hope you understand that. If I take the square root of x and then square it, I'm just undoing what I just did, so I get x. So this next shortcut is basically that, the next two. So log base b of b to the x power is going to be x, because you're saying, you know, without this x there, you're saying, well, what exponent do I need to raise b to the power of in order to get b to the x? Well, that would be x. B to what power equals b to the x? X. This would be b to the x equals b to the x. B to the x equals b to the x. So when you see log base 5 of 5 squared, it's going to be 2. Log base 7 of 7 to the third, it's going to be 3. It's like the log base b and the b all cancel each other out. Okay, vice versa. If you have b to the power of log base b of x, it's going to be x, because log base b of x is some exponent, so that if you raise b to that exponent, you get x. Well, then if you raise b to that exponent, you get x. So that's what this means. It undoes. If you take b to the power needed to get to x, you get x. So these two things kind of undo themselves. So if you understand what I'm saying, that's great. If not, for now, you can just memorize that, okay? B to the log base b is x, okay? So those are some shortcuts that come in pretty handy, okay?